Okay, I'm going to have a look at how to do a proof like this one. So we're asked to use the unit circle to show this proof. You have to reference the unit circle in this proof, otherwise you're not answering what the question is asking. So we're going to start off by drawing a unit circle. That's our unit circle. Now we're going to need a couple of angles, so always draw your theta around about 30, looking like 30 degrees, and put in the coordinates here. This is A, comma, B. Then look at the question, see which angles we've got involved. We've got pi over 2 plus theta. So this angle here is theta, and this rotation here is pi over 2. So the coordinates of this point here is going to be minus B, comma, A. So you're going to need a diagram like this one. And you can show that this is pi over 2 here if you want. It should be enough information. So the left-hand side is equal to the secant of pi over 2 plus theta. Now, the unit circle refers to the cosine of theta, comma, the sine of theta, like this. It doesn't talk about the cosec, it doesn't talk about the secant, the cotangent, or the tangent. If you're accessing those trigonometric identities, you have to relate them to sine and cosine. The only thing we get from the unit circle is sine and cosine. Otherwise, you're making an extra jump. You're making an extra jump which you're not showing as part of your proof. So you need to show the relationship between secant and sine and cosine. So for that case, that means this is going to equal 1 over the cosine of pi over 2 plus theta. This we can get off the unit circle now. So off the unit circle diagram, that tells us that the cosine of pi over 2 plus theta is minus b. So that will give us 1 over minus b. Now we're heading towards minus cosec. So we need to get our minus sign out from our quotient here. So that means we've got minus 1 over b. So at this point, we can insert from the unit circle that this is going to be the sine of theta, which is going to be minus the cosecant of theta, which happens to be the right-hand side. Notice how I take the minus sign out of the fraction in front of it, so I can just deal with the fraction on its own. So your proof, if you've had a go at this proof, it may look almost the same. One of the problems in these proofs is they all look very much the same. So you need to make sure your reasoning is correct. You may lose a point or so if you're missing a little bit of the reasoning on that one. I think that's it.
So don't you have to change
it? For a left-hand side, right-hand side proof, we don't, because we're showing the equality of the statement given.